to everyone. This is Kusnavani, Assistant Professor of Department of MCA in Robini College of Engineering and Technology. Today's topic is Object-Oriented Programming using Java. In topic Unit 1, Java Development Environment and Byte Code. The Java Development Environment in this process involved JDK and JRE and then JVM. In JDK, provide an environment to develop, compile and execute Java application. JDK is a combination of compiler, JRE, compiler in under bytecode. Then bytecode is a class file. JRE means Java Runtime Environment. JRE provide environment to execute Java application. Next, JVM. Java Virtual Machine is a core component of JRE. It allows Java program to run on any platform without modification. Java source code with the extension .java file. Then it compiled by Java C. It provide a bytecode, that means class file extension .class. JVM loads the bytecode and verify it, link it, and then execute it. And this is the structure of Java program execution. Assume that we can developing the Java program with the help of some editor, Notepad, Node+, like that, and we can compile this program with the help of Java C. That means Java C command. We can execute the program with the help of JRE. We will developing the Java program. The extension for the Java program is, that means source code is .java. Here what is the compiler will do is the compiler translate a high level Java program to bytecode. It is not a machine code. Machine code and bytecode are different. Whereas bytecode contains some symbols, whereas machine code contains in the form of 0s and 1 combination. The Java program will be given as an input to the compiler. The compiler will check whether it is contain any syntactic error or not. If there is error, if it will be displayed. Compiler produce the byte code. The extension of that byte code is .class. The byte code will be given to the input as the JVM. It already JVM. JRE execute the Java program. In order to execute the Java program, JRE contains the JVM. This is the architecture of the class loader file. First, the sample.java program will be given as an input to the compiler. It will produce the class file. It will load into the class loader. Then it produce the bytecode. That means what is JVM? It executes the Java application line by line. Let us assume that 10 lines of code. The Java access first line of the bytecode and execute it. Next, move on to second line of the code and then execute it. JVM, it is a platform independent. That means platform is a OS or hardware. Why it is called platform independent? Because each OS have their own JVM. That Windows, Linux, JVM codes is depend upon the OS. It varies from one OS to another. Java is both compile and interpreter based language. That means compiler produces the bytecode and the interpreter produces the output. This is a class loader subsystem diagram. Class file load into the class loader. The loader first move on to booster class loader, then extension class loader, then application class loader. Then all the processes are done. Then move to linking phase. Then move to initialization phase. In the class loader, read dot class file and store class metadata in the method area. Create class object in the heap, represent the loading class. Then linking phase are responsible for preparing the loaded class for execution. It includes 3 steps. First one is verification, then preparation and resolution. Verification ensure the bytecode follow JVM rules or not and is safe to execute. Preparation allocate memory for the static variable and assign default variable. Solution is convert symbolic reference into direct reference in the memory. Third phase is initialization. Initialization is assigning actual value to the static members or static variables. Execute static block defined in the class. Class loaders type. There are bootstrap class loader. Next is extension class loader. Then next is system or application class loader. JVM memory area. Memory method area, keep area, stack area, PC register, native method stacks. These are the memory JVM memory areas. Next is execution engine. Execution engine execute the class file only. It read the bytecode line by line, like as JVM. Uses data and information present in various memory area and execute instruction. It can be classified into 3 parts. That means interpreter, just-in-time compiler. That means JIT. That garbage tar. Next, move on to bytecode. Bytecode can be defined as an intermediate code generated by the compiler, that is class file, after the completion of source code. This intermediate code makes Java platform independent language because Java program is compiler is a dependent language, but Java is a independent language. Bytecode is the real power of mechanism which make platform independent and portable programming language. We know about Java is a collection of classes, so we know about what is the compiler. Compiler compile the source program, translate into bytecode with the extension dot class. If your program has 5 classes, then the Java compiler will produce 5 class file. But we have to execute the main class only. So that means that main method which is present in the class, even if we have 5 classes, but we want to execute main class only. So the JVM contains 2 things, that is Java class loader and Java interpreter. Class loader and Java interpreter. Class loader main into JVM for execution because the main class file is needed for the execution. So the JVM contain class loader and class interpreter. What is the responsibility of the class loader? It loads our main class into the JVM. That is need during the runtime or execution. The task of JVM is execute the Java program as line one, but the possible internally with the help of Java interpreter. Interpreter execute the bytecode line by line. Then bytecode move on to JVM. Then it will be some interpretation or done. Then move on to machine code. Bytecode generation compiler convert the bytecode or Java program into bytecode or machine. Then the interpreter execute the bytecode on the system. This is the overall concept of JVM and the bytecode. Thank you.